Now we're going to see what these polynomials look like as graphs. We did in the introductory video briefly look at the graphs of polynomials, but now we're going to look in greater detail at the graphs of polynomials. What we're going to do is we're going to look at the graphs based on the lead coefficient, the degree, the end behavior, and the roots. If you know all of this information, you don't really even need the function itself, but what's going to happen in your in some of your homework problems is you're not going to be given any of this information. You're only going to be given the function, and then you're going to be given some graphs, and you have to match the functions to the graphs based on the features of the polynomial, and that basically means identifying the lead coefficient, the degree, the end behavior, and the roots. Okay. So the first thing I'm going to do here is I want you to notice that this is the y-axis right here. Might be hard to see a little bit. And this over here is the x-axis, okay? And what we're going to do, the very first thing we're going to do is we're going to take all of our roots, -2, 7, and -8, and we're going to plot them on the x-axis. So if this is the origin right here, -2 is over here, okay? So what we're going to do is we're just going to plot -2. There's -2. Then 7. 7 is over here. 1, 2, 3, 4, 5, 6, 7 right there. Okay, so we're going to plot 7, which is right here, and -8 is all the way over here. Okay, there we go. So we have plotted -2, we've plotted -8, and we have plotted 7. Okay, and you can see that because the lead coefficient is negative and the degree is odd, that the end behavior is going to be down on the right. Okay, now remember, down on the right is just because the lead coefficient is negative. So we know that over here on the right-hand side of the graph is going to go down on the right. Okay, and that's what we mean by down. That's why we put this down arrow. Is literally you're going to see a down arrow on the right side of the graph. And that means that on the left side of the graph, we must be seeing an up arrow. And that's over here by the -8. We're going to see an up arrow, okay? And here's basically what we're going to do is we're going to take the graph from here and we're going to cross over each of these zeros. Now we're going to go all the way over to where the -2 is. We're going to cross over right there. And then the graph is going to cross over at the -8. And this is basically just very roughly, it's not perfect, but it's very close to the graph of this function right here. All right, now here's an example. We see our function, it's 4 factors right here, x plus 6 times x minus 1 times x minus 4 times x minus 7. And you can see that the number up in front here is 1, and in front of each of the x's is also a positive 1. So 1 times 1 times 1 times 1 times 1 is 1. So the lead coefficient is 1. There are 1, 2, 3, 4 x's all being multiplied, and so that means this has a degree of 4, and therefore the end behavior is going to be up, up. And you can see here x plus 6 means if we were to set this equal to 0 and solve, we would have a root of -6. If we were to set x minus 1 equal to 0 and solve, we would have a root of 1. X minus 4 gives us a root of 4, and x minus 7 gives us a root of positive 7. So we're going to plot all of these points on the x-axis. This is the x-axis. This is the y-axis. But the x-axis is what we're really concerned with. We're going to go all the way over to -6, which is right here. Then we're going to go to positive 1. Then we're going to go to positive 4, which is right here. And then positive 7, which is right here, okay? We know that because the lead coefficient is positive, that means that the right side arrow is going to be pointed upward. And now from there, we're going to go through here, then we're going to go through here, then we're going to go through here, then all the way over here, we're going to go through here. And look at that, the left side is also pointing up. See, we have up, up. The end behavior is up, up, okay? And that's why we draw these arrows as up, up, okay? Now let's try just one more example. Okay, this is our third example. We have f of x is equal to the negative of, so this is like a -1 right here, right? -1 times x plus 1 times x minus 3 times x plus 5 times x minus 6. And so our lead coefficient is -1. We have 1, 2, 3, 4 x's, therefore our degree is 4. because the lead coefficient is negative, that means that the right side is going to go down like that. And because our degree is even, our left side is going to be the same as the right side, which means down. So our end behavior is going to be down, down. Because of our factors here, x plus 1 gives us a root of -1, x minus 3 gives us a root of +3, x plus 5 gives us a root of -5, and x minus 6 gives us a root of +6. And so what we're going to do is we're going to plot all of these roots on the x-axis. Okay, here's the x-axis, here's the y-axis. Okay, and so we have -1, which is right here. We have -5, which is right here. We have +3, which is right here, and we have +6, which is right here. Now it's important to know that the coordinates of these points are, like this one is -5, 0. Okay, this one is going to be, -1, 0. So if you're asked, these are the same thing as the x-intercepts. The roots are the x-intercepts of the polynomial if you were to add a 0 on to, put a ,0, because it's a point. Okay, +3, 0, and +6, 0 is this point over here. Okay, so I'm just pointing that out so that you understand. So we that these are points, that the roots are the x-intercepts. It's the same thing. Okay, of the polynomial. And we did this previously, something like this with quadratics. All right, and so now, because the lead coefficient is negative, we know that on the right side, the graph is pointing down. Okay, so down. Then from there, we're going to go through 6. Then we're going to come around and go through 3. Then we're going to come around and go through -1. Then we're going to come around and go through, whoops, that's a little ugly right there. Let's try that again. All right. We're going to go through 6, through 3, through -1, and then through -5, but we have to go kind of down and to the left there. There we go. And now you can see our end behavior is down, down. Okay? And so this is roughly the graph of this function right here. Okay? In the next video, we're going to go into a few more details about the graphs of polynomials.